Using my interpretable machine learning app that I've coded out in the R language, I've went ahead and set our mode of modeling to classification. We'll leave the train data to be split into 70% train, 30% test for evaluation. We'll go ahead and load that data in now. Alright, so we're going to let those models train in the background real quick and then come back and check out the best model and choose the interpretable machine learning output from that model and interrogate how it predicts what it predicts. The models have finished training now, and since we chose classification, the only models we have in my app at this time for that is Random Forest and XGBoost. So between those two classification models, we want higher numbers in these performance metrics here, and it appears that the Random Forest had the higher accuracy, but even more importantly had the higher area under the curve at 0.843, where random chance would be 0.5. And XGBoost was also above random chance 0.5, but just not as good as Random Forest in this case. So we'll go ahead and choose Random Forest as our model of choice to put out into our interpretable machine learning output. Okay, so we have our interactive studio to interpret the Random Forest model now and how it predicts whether a given DNA site is going to be hypersensitive to DNAse 1 or not. We can see the feature importance over here with the dinucleotide breakdowns of the DNA sequence, where CG seems to be the most important by a long shot, followed by CA, TA, GC, and then the various other dinucleotides. We can also look at some of the other outputs of this model, such as the distribution of a given dinucleotide against the response target. We can also look at the Shapley values, which show an order of decreasing magnitude of importance, the effect a given dinucleotide count has on the DNA sequence that we're looking at here. In this case, it's DNA sequence 1, but we could as well choose 2, 3, 4, 5, etc., and it updates with each one. And then on the right here, the breakdown of the prediction of this specific DNA sequence, starting from the baseline probability and then how each dinucleotide pair count affects the final prediction.